1.7, dividing whole numbers. So I know what a dividend, divisor, and quotient are. Dividend always reminds me of that, I think it's a yellow card in Monopoly, which I tend to win at because I also tend to cheat. I'm trying not to, though. But the second objective, I can divide with whole numbers even if there are remainders. So division, as much as we've anticipated it here, it's here. And we are ready to love it. So vocabulary with division, and we do have the division symbol here at the top, right? At least this is the base, kind of our basic, most foundational division symbol that we have. And again, it is a symbol, so it does represent the actual word division. So if you read this symbol, you should read it as division. But you're going to have two numbers that you're going to be dividing, okay? When you divide these two numbers, the first number is called the dividend, and I will be referring to this vocabulary quite often. So probably don't refer to values in division with this type of vocabulary, but in a math class we will. So I'm just telling you to be ready for it. And then the second value is called the divisor, right? First number divided by the second one, dividend divided by divisor, and then our final answer will be called a quotient. Now, why is it called a quotient? I actually have no idea. I assume it has something to do with Greek or Latin, but I just don't know. Same with dividend and divisor. I didn't make up these words. I don't think I would have come up with those if I was asked to, but when we divide, we get to this question here at the bottom, okay? How many times will the divisor, that's the second number, fit into the first number, the dividend? Okay? So in other words, and this may work better for some students, they like to think about this better in terms of taking the dividend, and you're going to split it up into this many groups. I'm just throwing everything out there, hoping that something sticks, okay? But first number of the dividend, you can split it up into groups, or you can ask yourself, how many times does this one fit into the first one? It's up to you. And then right here at the bottom, so sometimes the divisor doesn't always fit exactly into the dividend, and that's where we get remainders, which was part of our objective. So we'll see more of that kind of stuff. Okay, so more division stuff. We got 12 divided by 2, 12. By the way, these all read 12 divided by 2. Like this one, of course, 12 divided by 2. Fractions like this, it still reads 12 divided by 2, okay? Sometimes they show division with just a little slash, and this tells you how much I know, but I don't know if this is forward or backslash, and I also don't care. But it's 12 divided by 2, that's how that reads. This is the one that catches students off, because a lot of students look at this one, they say 2 divided by 12. No, that is not what this is. This is 12 divided by 2. Again, it's how many 2's go into your 12. This is what we call long division, which we're going to get into today. Now, if we have just regular division symbols down here, it's possible to change a division problem back into a multiplication problem. The two are related. They're called inverse functions or operations, inverse operations. And you can switch between the two, just like it's showing here. Like if you had 12 divided by 4 equals 3, you could replace this. Now that's dividend of 12 divided by a divisor of 4, right? 12 things divided amongst 4 people, everyone gets 3 things. But you could say, well, three groups got 4 things each, and so you'd have 12 total things. So that's the relationship here with, this is called the fact family, which we've seen already, I think. Now, as it turns out, the multiplication table, we see it again in a division section, because you can divide with the multiplication table, right? Because of the fact families that we just saw on this last slide. So, for example, let's take 30 and divide it by, you guys want to divide by 5 or 6? 5. I guess we could do like 3 or 10 as well, but let's do 30 divided by 5, okay? So if we saw 30 divided by 5, now again, we want you to memorize this multiplication table as soon as possible, which is part of your extra 12 hours outside of class, right? But at this point, I'd say, look, it's a dividend of 30 Now, as a multiplication problem, the dividend is 30, so that ends up being our product in a multiplication problem. And then the divisor here, 5, is one of the factors. Now, I'm putting it as the first factor here, but if you wanted to make it the second factor right here, that's fine as well. 5 times what is 30? So again, this is where this comes in. I find 30 as a multiple of 5 right here. So again, it is being multiplied by the 5. I'll use red there. But then what else would 5 have to multiply to get 30? Well, then we can just kind of trace it back to the, I guess the row here is 6. So that would end up being 5 times 6. Whoops. Which means that 30 divided by 5 is 6. Now think about this. If we were to switch these, and this is going with the fact family stuff. If I had done 30 divided by 6, you may have used the same 30 right here. The other one you could have used was this one. But this one right here, you would have traced this back to 6. So you know it's multiplied by 6. And then you would have said, well, okay, then 30 divided by 6 would have to be this other factor of 5. So that's our fact family right there. The good news is, as well, is that both of these division problems also become this multiplication problem. So if for some reason you understand the multiplication stuff better and you have the chart memorized especially, then yeah, you may want to look at these and say, you know what, I don't like this division problem. I would like to see it as a multiplication problem. Feel free to do that because you can. Some people can just divide and that's fine too, which we're going to look at. Times table above, we'll use these fact families. So we got 49 divided by 7, okay? So again, we got dividend and divisor. So we can change this, I don't know. We can change it into a multiplication problem. I'm just kind of throwing things out there. So our divisor is 7, so that becomes a factor. And then the quotient for that would be here, I guess it's a blank for me. It's the other factor, okay? So in a division problem, the divisor and quotient are factors multiplied together, and then the divisor is the product. Okay, now again, I don't know if this multiplication thing helps. Some students are like, I just know 49 divided by 7 is, I already know what it is, okay? I don't know if you know that or not, but either way, this becomes our multiplication problem, and you could see that you can then use the multiplication table. Well, there's 49. And I see that 49, there's a 7 right there. 7 times something will be 49, but it looks like it's also 7. So that kind of goes back to our exponents. It's really 7 times 7. But for a division problem, right, for multiplication, we'd say 7 times 7. But then 49 divided by 7 as a fact family gives us 7 as well. Okay, 48 divided by 6. You can't just use the chart directly. I guess since you guys expressed it though, right? The 48, our dividend in the multiplication problem will be our product, 48. And then, well, our divisor will be our first factor. I just always make it the first factor. You can make it the second one, doesn't matter. But I see up here, 48, found it. Some of you may have used this 48, and you're going to get the same answer either way. But I see that it's multiplied, 6 multiplied by something. Well, I follow this back over, boom, it's 8. Now again, that gives us immediately the quotient, but it also gives us the other factor in the fact family. Okay, so if that's what you got, 11 and 10, again, you're using the chart. So let's see, 22, again, you can find 22 here. So there's well, I guess the 2 would be up here and then the 11. But maybe use this 22, I don't know. It doesn't matter because of the commutative property of multiplication. Or you may have used, where's my 90 or 90 right there, either one of those to get the 10, doesn't matter. Let's go back to what division is asking, right? This is asking how many 7s are in 49? 7 of them are. Okay. Or how many 6s are in 48? There's 8 of them. How many 2s are in 22? There's 11 of them. How many 9s are in 90? 10. 10 9s. And that's where the multiplication may be helpful, right? 7 times 7 is 40. It's kind of like backwards here. 6 times 8 is 48. 11 times 2 is 22. 10 times 9 is 90. That's okay when we start using values that are within the range of our chart, right? Our multiplication table. The problem is not all of them are. So this is where that long division stuff comes in. And again, the one that we saw, like something like this one. Now again, we have to be careful with the way that we read these. That is not 2 divided by 12, because as it's showing here, the dividend is inside the division symbol, and the divisor is on the outside. So this is actually reading 12 divided by 2, which is backwards, of course. I'll point this out as well. So long division is a great way to break a large number up into smaller, more manageable parts. It's kind of by place value, kind of. And it kind of borrows from other place values, but instead of going from the smallest place value, which would be 1s, we start with the largest place value, which it depends on what number we're looking at, right? So in other words, long division, let's even look at this one, 12 divided by 2. This one we would first ask, how many 2s go into 1? Now I treat that 1 as a 1, not a 10, unless it's too small to have the 2s go into it. And it is, by the way, which means I would have to treat this as 12, okay? So from long division like this, you can see that the quotient ends up being on top of the division. I'm going to call that division bar. And we will align the quotient up with place values. So if any values cannot be divided, we tend to put zeros there. I recommend putting zeros there until you get really used to it. Here's what I mean by that. So for 12 divided by 2 up here, I would say first start by looking at just 2 divided by 1. Okay, so I just cover up my 1's place value. I don't care that it's there. But I would say, you know what? 2, it doesn't go into 1 because 1 is too small. So you can put a 0 there, and that's okay if you do, to hold that place value. But then you would look at the number, so like I was saying, it's kind of like borrowing, kind of, where we're saying, now look at this 2. Does it go into 12? 12 is big enough. And we'd say, well, how many 2s fit into 12? Well, there's 6 of them. Now, 06 can be your quotient. You don't have to show the 0. In fact, I'll erase it. But that would be our final quotient because 6 goes into 2 evenly. Just to show you the work on this, we then do the quotient times the number that we're dividing by, which is the divisor, 6 times 2, which is, well, 12. Now, this 12 in green is a value that was used up. 6 times 2, that goes into 12. 6 times 2 is 12, meaning all 12 were used up. And this is why, and I hope you've seen this before, this is why we use subtraction as we go down long division. Because the green 12, that's how much was used up of the original black 12, which means that you have a remainder. There's our R of 0. Here's our first number, 6,819 divided by 3. Now that's quite large. I do not know my 3 times tables up to 6,819. If you do, that's pretty freaking awesome. I just don't. So I am going to use it. I think it might be too small. Anyways, I'm going to use long division on this because I just can't do it in my head. Now, again, if you can, that's great. I just can't do it. So let's set this up with some long division, and hopefully this will help us to love it so much. So our dividend, 6,819. And I have put some distance between those, each place value on purpose, because with long division, we're usually going to need some space. Okay, so there's my division symbol right there. And it is just kind of an open parenthesis or closed parentheses there with a line crossing over it. But that's long division. And our divisor, 3. All right, if we're good with the setup, then we're ready to start the division. Now again, with long division, we start with the place value furthest to the left. You can treat that as 6,000 if you like, but we don't want to do that in case we need to borrow, I guess, is what we're going to call it. So I say, how many times does 3 go into 6? Well, last time I checked, it was 2. 2 times. Now, again, that means 2, so I'm going to show the multiplication here. 2 times 3 is going to give us the value to take away from 6 because it was used. Okay, so I took this 6, I divided it amongst 3 people. Each person got 2, so I used up all 6 of them. Okay, so the 6 has nothing else remaining. All right, well, let's extend this. I'm going to extend this line on purpose. And if you can draw straighter lines than me, that's great. I just don't expect anything special from my straight lines. Okay, so I'm going to move this over, and I'm going to take that 8 and I'm going to drop it. Because I just want to look at that as an 8. In fact, the 0, like I said before, I'm going to make that go away. I don't want to look at that garbage. Okay, so now, okay, let's get rid of this stuff so we can use it again. I'm looking at the 3 and the 8. Okay, how many times does 3 go into 8? Well, it's 2 times again. So, I'll use a different color. 3 will go into 8 2 times. Now, does it go into 2 times completely? No, it does not, and that's okay. Here's what's going to happen. So, 3 goes into 8 2 times. 2 times 3 is going to be 6. That means of the 8, we only used up 6. I can do a little bit better than that. There we go. I'll call that good. Okay, so from the 8 that we had, we only used up 6. We're left with 2. So 2 is too small for 3 to divide into, which is kind of what we expected. And so we're going to take the 1 from the next place value and drop it. And this number now we treat as 21. Okay, so let's clean this up. So I got 21, and now I'm asking myself, how many times does 3 fit in 21? 21 is a large number, but it fits on our multiplication table, right? Well, you can check, but it is going to be 7. Okay? Now, it will split evenly 7 times, meaning if I were to go back and say 7 times 3, you will get 21. So that means all those 21 that we started with, we just used up. We split it amongst something or people, and that gives us nothing remaining there. In the 1 minus 1 or the 2 minus 2, zeros. Boom. Should have extended that a little bit. So, last up, I've got the 9 that's left over. In fact, that's all we got left of the number. And so we're going to take that 9 and we're going to drop it with the zeros. Okay, so there's my 9er. And now at this point, I don't really want those zeros because, I don't know, it's kind of distracting. I just want to look at the 9. Well, now we get to ask, how many times does 3 fit into 9? Well, 9's not too big. 3 will fit into 9 3 times. And 3 times 3 is 9. So when I subtract this out, all 9 of them were used, and I have a remainder of 0. That completes the problem, which means that we have found the actual quotient. I'll write it in black, though. So 2,273. We did it. We made it with long division. All right, so let's set this up then with some long division, which we are now enjoying at full blast. So we got our dividend at 270. So I'm just going to set up my long division here. Let's see if I can. It seems like enough space. So 270. And we're going to divide this by 5. If we can start well, then we can at least start the process, even if it's just a little bit. So once again, I'm going to just ignore all the place values to the right, which is only 2 place values, the 1s and 10s. I'm looking at the 2. Even though it is 200, I don't look at it as 200. I'm just looking at it as 2. Now, how many 5s will fit into 2?
Okay, that's where I missed.
No of them will fit. All right, so it won't go into 2. So again, I've just slid this over because I need to make that 2 bigger, and now it is 27. It is bigger. And 5 will fit into 27. Not exactly, but close. It fits into 27 5 times. Okay, so there's my 5. at this point, I'm gonna get rid of the 0 over the 2, okay? So I put the 5 over the 7 because I'm looking at it not just as a 7 by itself, but as 27. So if you want to keep the 0 there, you're welcome to do it. But right here, I'm just going to get rid of it so it doesn't get in the way. Now, 5 will go into 27 5 times. Not exactly, though. So how much of the 27 was used up? Well, 5 times 5 is 25. So if I take that out of the 27, of the 27 that we started with, we used up 25, which means we're left with 2. I need to extend that a little bit. Now that I've cleaned that up a little bit, I'm going to slide this over. It was just originally 270, so I can get rid of the box. And I can now take the 0 in the ones place value and drop it to make that 2 large enough for 5 to go into again, and it becomes a 20. So, again, I'm not worried about the 270 up here or the 25. We've already dealt with that stuff. All I'm looking at is how many times does 5 go into 20? Well, there we go. It is 4 times, and it's 4 times exactly because 4 times 5 means that of those 20 that we started with, we just used up all 20 of them, and so we have a remainder of 0. Therefore, our final quotient is 54. So division and remainders. So on those last 2 problems, long division, excuse me, we didn't have any remainders. That does happen from time to time. So there's our example. I don't know how good it is. But you cannot divide 53 Hot Wheels evenly among 10 kids, right? So you could say, well, if there's 10 kids, 53 Hot Wheels, yeah, each kid, all 10 of the kids can get 5 Hot Wheels each, but the problem is you got the 3 left over. Now of course, mathematically speaking, we just say those 3 are just called a remainder. It doesn't tell you what you can do with them, right? Like, of course, if this was maybe a more real life example, you'd say, you know what, the first 3 kids get the extra 3 leftover cars, and then they get 6 each, whatever, okay? But again, mathematically, we say, well, they each get 5, that would be the quotient, and then it has a remainder of 3. But it's not telling you what to do with the 3, okay? All we know is that there are 3 left over, and that's all we would need to know for a math class. So sometimes when these values happen, you just can't divide them evenly, but you have something left over. The homework has a separate box for this, and it can be placed in different spots, so I can't really demonstrate that exactly. So we want to find the quotient and remainder, and we're ready then for some long division, which we enjoyed so much. So I'm going to take my 8,882, and I will divide it by 9. Okay, well, process is going to work the same. We start with the place value furthest to the left, which is the thousands place value. I don't care that it's the thousands place value. It just happens to be the place value furthest to the left. And I get an 8. All right, there's an 8. I ask myself, how many times does 9 go into 8? Okay, how many 9s will fit into 8? 8 is too small. So no 9s will fit into 8 by itself. All right, since no 9s will fit into 8, I'm going to take the 8 and kind of expand it into the next place value and treat this as 88. Now, just so we understand, no number should go into any of these numbers that we're working with more than 9 times, which is why we deal with one place value at a time, okay? So, we say, how many times will 9 fit into 88? You know what? I'm going to do this as well, okay? Now, this may help us even if we don't have our multiplication tables down. I was going to wait to one of the future problems and do this, but I'm going to do it now. So what we can do is we can kind of speed up this process because 88 is kind of a big number, and I mean 9's not so big. It is part of our multiplication table, but we may not have those multiples memorized. But we can make a list of the multiples. Well, I'm going to do it over here. So I'd say, you know what, 9 is its, there we go. 9 is its own first multiple. I should make that smaller. Okay, I put a check mark next to it because it's its first multiple. We don't want the 0th multiple because that doesn't help us. But 9 at least is its own first multiple. That's good. Now, I'm going to make all the multiples of 9 up to 9 of them, because that's all I ever need is up to 9 multiples of any number that I'm dividing. So if I wanted the second multiple, I'd just say, you know what? I'm going to take that 9 and just add another 9. And that would give me my second multiple, 18. Boom. Okay, so 18 works, and then we just repeat this process. Here is my list, and I've made check marks next to each of the multiples right there, which means I don't necessarily need to memorize my multiplication table. I can just look at this chart as I do my long division and say, well, how many times does 9 go into 88? So 88 is just bigger than 81. Anything beyond that would be the 10th multiple, so it can't be that far. So it has to be 81. That's the 9th multiple, which means that 9 goes into 88 9 times. 9 times, there we go. Either way, we got that. So we got the 88. How much of the 88 was used? Well, 9 times 9. We already know that because we have our list. 9 times 9 is this 81. So of the 88, we used up 81. And so we're going to subtract that. So here we've got 8 minus 1, which is 7. 8 minus 8 is 0. I don't really need that 0, so it's just going to keep that 7. And 7 is less than 9 because if we have anything remainder, it can't be bigger than what we were dividing by. So 7 is okay to have right there. So we're going to move this over, and we're going to look at the next number, which is an 8. And take that 8 and drop it here. And now I'm looking at 78. Excuse me. Well, 78 is just below 81. 81 would be too big, which means that 9 will go into 78. Not exactly, but close. It's 72. It'll go into it. That's 72 is the 8th multiple of 9. Okay, so I've got my 8 there. Let's clean this up a little bit. All right, so how much of the 78 was used? Well, 8 times 9. I just look at my chart right here. 8 times 9, we used up 72 of the 78. So using up means we're going to subtract here. So extend that a little bit. And now 8 minus 2 is 6. So if I put a 9 right here, then I would have had 9 times 9, which is 81. But I didn't have 81 to take away from it. So 9 would have been too big. That's why we say 78. We go to 78 is not an exact multiple of 9. So we go to the next one down, which has to be 72. That is the 8th multiple of 9. Okay, so this is what we're left with. We got that 2 in the ones place value that I'm going to drop with the 6. Now it is a 62. 62 is also not an exact multiple of 9. It's pretty close. It's pretty close to 63. Now again, I'm going to do this wrong on purpose. We don't want you to make this mistake, but I'm going to show you something that could happen here. Some students would say, well, it's very close to 63, and that's the 7th multiple of 9. So you can say, well, 7, it's the 7th multiple. This is incorrect. I'm just giving you an example. Why 63 does not work? It's because you had only 62 to start with, but now you're saying you used up 7 times 9, which is 63, and now you're saying, you know what, you're going to take out 63 from 62. You've taken off too much. So the 7th multiple of 9 does not work, meaning we got to go one more down from it. So again, you always look at the number, and then you go one multiple down from it. Okay, it doesn't matter how close it is to the next multiple. Again, like 63, it's close to 63, but 63 is too big. So we got to go down 1 to 54, which is the 6th multiple of 9. Okay, that's our 54 there. Now we're not using 63. Just get rid of that. We are using 54, which is the 6th multiple. So I already know from my multiples list on the right there that 6 times 9 is going to be 54. So of the 62, we're only going to be able to use up 54. That's not exact, but it is all of the place values that we have to work with, which means that we're automatically guaranteed a remainder on this one. I can't do 2 minus 4, but I can do 12 minus 4 by borrowing from the 6. 12 minus 4 would be 8. 8 is smaller than 9. Yeah, that's what we expected. So my final quotient, I will write, we got 986 with a remainder, there's my R, remainder of 8. Now be careful, I did write the 0 there. Notice I did not write it in the quotient. If it were something like a written test, I would be okay with it. But eventually you'll be like, you know what, that 0, I don't like it there either. And, well, I'm a math nerd, so I don't really like it there either. So I got rid of it, but whatever. Let's go through this one and get a quotient and a remainder. The product of a number and a natural counting number, and we get those multiples. I guess I used that maybe a little prematurely there. But let's say, for example, we wanted multiples of 4. This is a list of the multiples of 4. The first, well, 13, including 0. We don't really include zeros, and there's a reason for that. We'll get into it, but you always start with the first one, and then you just kind of list the other multiples. The reason why this is important is because so far we've only been dividing with one-digit numbers, which all fit into our multiplication table. And if you have that memorized, then finding the multiples isn't usually that rough. But once we go beyond 12, then we're outside the bounds of the table, and we don't have those memorized. So we may need to make a table, just like I did in that last problem, a couple of problems ago. I would plan on, if I see the divisor being anything more than 12, to make a multiples table so I can refer to it back and forth, and I don't have to go through my head, because this is essentially what you'd have to do without it. You have to keep thinking, well, how many times does 54 go into 800? I don't know, something like that, right? But if you have the multiples listed already, like I did on the right, then you're ready to go, and you can just kind of refer back to it. Does it take some time? Yes, it does. But I hope that you find that it's helpful. And just like we did before, you can do it with smaller values, but again, we would want you to have those memorized as soon as possible. 17 is a fabulous number. Okay, well, we could divide this right away and be like, you know what, we can just do it. And maybe you can, all right? But it's possible we may need some of the multiples of 17 because I don't have them memorized. And if you have them memorized, that is freaking awesome. I just don't have it. So, I'm gonna go to the right, and I'm gonna start with 17, which is its own first multiple. Like I said, I like to put check marks next to them. Maybe it'd be good if I numbered them so I could tell which multiple it is, but I haven't gotten that sophisticated yet, so here we are. So 17, right? To find the next multiple, I've got to take 17 and, well, add another 17. That will give me my next multiple. I'm going to skip a little bit of the addition right there, but that's going to be 34 because you'd have to carry the 1. So 34 is the second multiple of 17. And then the next multiple, we'll add another 17 there. And that will give me the third multiple. So that's 1, carry the 1, 51. Okay, so 3 multiples. Remember, you never have to go past 9. I'm actually going to stop at the 5th multiple and see if we need to go past it, which just may save us some time. So we'll add another 17 here with the 51, and that will give me the 4th multiple, which appears to be 68. And then adding a 17 again. I'm going to stop at the 5th multiple. We may or may not need more. I don't know, because I don't have my 17 multiples down yet very well. Well, I actually just don't have them, but either way, there's 15, carry the 1, 85, boom. 5th multiple, let's see if this is enough, okay? So I'm gonna go into my long division process, 246 divided by 17. Okay, so I have my chart there that I can refer back and forth to. It may work, maybe not, we'll see. So I'm gonna start with, by covering up the values. 17 is way bigger than 2. 17 will not go into 2 because 2 is too small. So we put a 0 there, boom. And we look to the next value and make it 24. Well, 24 is not too bad. 24, not 34, but 24. 34 is too big, so I just go back to my first multiple. It only fits into 24 one time. All right, so let's clean this up. So I take the 1, multiply it by 17. That's as much as we used up of the 24, 17. Okay, so we used it up, so we're subtracting. Again, I would treat that as 14 minus 7, borrowing from the two 10s. 14 minus 7 is 7. Okay, now 1 minus 1 there ends up being 0, but I don't really need that 0 there, so I'm going to get rid of it. It's garbage. All right, let's move this over. And we're going to take that 6. I'll extend this so we know what we're dealing with. I'm going to drop it and make that 76. Well, we won't need anything beyond 85 because 76 is less than 85. So I tend to stop at 5, and then if I need more multiples, then I will add them in as we go. But 76 is okay. Again, I can't go up to the next multiple. I've got to go to the next multiple down, which is 68. And 68 is the 4th multiple of 17. So again, I don't really have to think about this. What is 4 times 17 because of the list? I already have the 4th multiple of 17 at 68. So 4 times 17 means of the 76, we used up 68 of them. And so what do we got left? Well, that'd be 16. So I got to borrow from the 7 there. 16 minus 8 would be 8. And then 6 minus 6 is 0. I don't really need that, but that uses up all our place values, which means I have a remainder of 8. So our final answer is 14 with a remainder of 8. Okay, so some long division here. Actually, before I get into long division, even setting it up, let's look at some multiples of 25 and see what we got. So my multiples of 25, I'll start with the first one, of course, which is just 25. So if I add another 25 there, some of you may not even need this addition here, but some of you may, and that may help. It's a 50 plus another 25 is going to be 75 plus another 25. That's the 3rd multiple. This will be our 4th multiple, 100. And then plus another 25 is 125. Here's our 5th multiple. I need to go higher. So we'll add another 25 there to get 150. And yes, I am skipping some of the actual addition process here, but it's just for the sake of time. So 175, and then finally another 25. So our 8th multiple is 200. Okay, so check marks next to all of the multiples. 125, 100, 75, 50, and 25. Okay, so 8 multiples. I could do another one, but we'll skip that for now because we actually don't need it. Now we can set up the long division. So we got 13,695 divided by 25. Okay, but we got our multiples of 25 there on the right. So everything should be taken pretty well care of. And let's kind of get rid of this stuff. Now, here's the thing. 25 doesn't go into 1, right? But in addition to that, by moving this over, it also does not go into 13. So you can have 2 zeros here. That's not a problem. But if I move this over again, now it's going to work. 125 doesn't go into 136 exactly, but it will go into it. Looks like that's our 5th multiple. 125 is the next one down from 136. So 25 will go into 136 5 times. Again, I don't really need to do the multiplication there. 5 times 25, I just know that it's our 5th multiple is 125. So I don't really need to do that multiplication either on paper or in my head. So subtraction now. 6 minus 5 is 1. 3 minus 2 is 1. And then the 1 minus 1 is 0, which we're going to just kind of get rid of there. Okay. So that's a little bit cleaner. And now we've got the 9. Should have extended that. The 9 we're going to drop to make the 11, now 119. Now I look at 119. Let me move this because I need it. 119. 125 is too big, but I can go down 1, and that's 100 right there. And so I'll keep that 5 covered. 25 will go into 119 4 times. Okay, now again, 4 times 25. I already know from my chart that we would have used 100 of the 119. And then with the subtraction, you would have 19 left over from that 100 that was used up. So just cleaning up a little bit. There we go. All right, 19. Okay, let's look at the next place value, which is a 5. In fact, that's all of them. So I'm going to take that 5, extend this, and drop the 5. So that reads 195. How many times does 25 go into 195? Well, 200 is too big, which means that we're going to have to use the seventh thing. Counting's hard. Seventh multiple. So there's our 7 right there. And again, 7 times 25 would give us, again, I don't really need to do this because I've already got that multiple of the 195. We're going to use up 175, which leaves us with 20 remaining. Again, there are no other place values to drop, which means the 20 is just left over. And so our final quotient then is 547 with a remainder of 20. I would like to see more of this actually, because I don't know why, but as a math nerd, I kind of geek out about this, but dividing by 1 just makes me so happy inside. Actually, anything divided by 1 is itself, anything. So if you took a bag of sunflower seeds and divided that amongst one person, that one person would get the whole bag of sunflower seeds. You see what I'm saying? Because anything divided by 1 is itself. If you took 350 Hot Wheels and split them up amongst one person, that one person would get 350 Hot Wheels. You see what I'm saying? If I had 5 apples and wanted to split them up amongst myself, I would get 5 apples. And that sounds kind of selfish. If that's what you got to do to memorize this, that's fine. Anything divided by 1 is itself. This is a very nerdy way to show that. It's called abstract. Not that I suppose you care. But we can show with numbers, right? 5 divided by 1, well, if you're taking 5 things and dividing it up amongst one person, that one person gets 5 things. Or 7 things divided by one person, that one person gets 7 things. Boom. Okay, so anything divided by 1 is itself, which means that when you see this on the assignment, which they will give you, just know that whatever your dividend is, the first number or the top number in the fraction, the dividend is your actual answer as long as your divisor is a 1. So with division on base 10s, now there is reasons for this, but right now we don't really care about those reasons. We'll get into it later though. But for now, all we got to know is that if we have this example, 3,000 divided by 5,000, what we do is we start to the right, and any zeros to the right that match on the top and bottom, we can, I don't want to say canceled out. You can say canceled if you'd like, but really what happens is they become phantom ones. More on that later when we look at the factors of these numbers. But this 0 and this 0, I would say, you know what? I just don't like them, so I'm going to get rid of them. So again, you can say you cancel them if you'd like, but I'd say they become phantom ones more specifically. But also I got another set of zeros right there. Boom. Now notice I started as far to the right as I could go. These 2 zeros furthest to the right, and then I crossed them out. That's a 1, by the way. And then these 2 zeros as well, I crossed those out with a 1. And this is what I'm left with. Now that I've gotten rid of them, I'm now left with 30 divided by 5. And, well, since we have our multiplication tables down, how many times does 5 go into 30? 6 times. Bam. Nailed it. So this means the original problem, how many times does 500 go into 3,000? It would have been 6. But by getting rid of the zeros, it makes it something a little bit more manageable, I hope. That's what we all hope. And so that's what we do. Okay, so this is not set up as a fraction like the last example was, but I can see that my dividend has a 0 on its back end, and same with the divisor, which means that those zeros, I'm crossing those out because I can get rid of them. And now what I'm left with is 80 divided by 2, which to me, I think is much easier. You don't have to agree with that. Now, we don't have our 2 multiplication tables up to 80, and that's okay, because now what we can do is use long division. So 80 divided by 2, I'll do this fairly quickly, but 2 goes into 8 4 times. 4 times 2 would be, well, 8. All 8 of them was used up. So we got nothing left there. Now, if I drop that 0 there in the ones place value, what happens a lot in these scenarios is students will be like, it's 4. Well, I know 2 times 4 is 8, but it's not 80. What we have is that 2 will not go into zeros. Well, I guess you could say it goes into it exactly 0 times. So the final answer here ends up being 40. No remainder on this one. I don't expect any, but I suppose you could. We shouldn't expect any. So there you go. 40 would be our final quotient on that first one. I'm going to do this just one more time, real quick. Okay. Another way we can do it with division with zeros, especially if they're coming from the dividend, which is the 80 in this case. What you can do is you can say, you know what, I'm just going to take this 0, tack it onto my answer, and then actually all I got to do is 8 divided by 2, which is 4, and that would give me the first number in, well, the 40 right there. Now, if the 2 didn't go into 8 exactly, that's fine. We would have to actually use the 0, but I don't expect that we're going to see that yet. Let's do it, okay? So that's our answer right there. Let's see what happens. And so I look at the tail end of this again, both numbers. We got zeros, boom, get rid of them, okay? Same with the next 0. There's 2 zeros that we can get rid of from both numbers. Now, this changes it doesn't change the overall value, but it does change the way it looks, meaning that we now make this 1,500 divided by 3. Okay, now, I mean, you can use long division. In fact, we'll show it that way. You could just say, you know what, you got the 2 zeros and 3 goes into 15, and that's fine as well, but I'm going to skip that garbage. So, long division. Okay, so again, this makes it much easier for us. 1,500 divided by 3. And 3 will not go into 1, but it will go into 15 5 times. 5 times 3 is 15. When I subtract, I get nothing left over because it went into 15 exactly 5 times. So let's make this pretty. We'll get rid of that 0. And now, as I drop more zeros, so in the tens place value, well, how many times does 3 go into 0? 0. Well, how many times does 3 go into 3? 0. Oh, man. How many times does, I don't know what's going on here. Technology. How many times does 3 go into 3 zeros? It's getting worse. Another 0. Another 0 times, exactly, by the way. Which means that you could say, you know what, you got 0 remaining, and that's fine, but that's where our 500 comes from right there. The 500 that we got. Well, all of that we just barely did, it's going to help us when we look at dividing with rounding. Because what we're going to do is just front-end rounding, it looks like. Since it's front-end rounding, we should only have one individual place value in the front of both the divisor and the dividend. And then we just get to cross out a bunch of zeros, which is fabulous, if you ask me, because it's going to make this very, very quick. So then we divide with the rounding numbers. You have to round first and then divide second. But we're looking for those zeros to cross out. Hinders on this, and that's okay. So I got my 451. Let's round that. Front end means I'm going to round where the 4 is, the hundreds place value. Immediately to the right is a 5, which means I'm going to round the 4 up 1. I'm going to add 1 to it and make this 500 instead. Now I've got the 72. I'm rounding, again, just to the front end is the tens, and that's okay. I'm rounding to a different place value because it is a different number. But the 2, immediately to its right, is going to keep the 7 a 7, but it's going to make the place value to its right a 0. So I end up with 500 divided by 70. And once again, we see that the zeros on the tail end, there's only these zeros to match, become zeros. They become, I don't want to say cancel, that become phantom ones. So this problem becomes 50 divided by 7. So it looks like, again, we're expecting some remainders. Okay, well, 50 divided by 7. 7 will not go into 5, but it will go into 50 7 times. 7 times 7 is 49, and so I end up with a remainder of 1, and that's okay. So I have a quotient of 7 with a remainder of 1. That's after the front-end rounding, of course. But we started with the 451. If you actually did 451 divided by 72, of course, you'd get something a little different. Okay, we're going to do the same thing with 372,581 divided by 983. Okay. All right. The 7 right there to the right of the 3 is going to add 1 to our front end of the 3, which makes it 4. All other place values to the right, all 5 of them in this case, become zeros. So that ends up being 40,000 divided by, we got to be careful on this next one. We made this number up. And so you got to be careful with this on the assignment because I believe they do this as well. We're rounding with the 9. Immediately to the right is an 8 though, which is going to add 1 to the 9 to make 10. And then again, you got these 2 place values here that have to become zeros. So just be aware that can happen, and it just did. So just take care of it if you need to. But now I've got some zeros that I can become phantom ones. Okay, there's 2, and then I can get 3 zeros to match, which now changes this problem into 400 divided by 1. And great news is we just went over this. Anything divided by 1 is itself. So we end up with a final rounded value of 400. And then our last slide right here, dividing with 0. So sometimes 0 is the dividend. Sometimes it is the divisor. We just, but it gives us something different, okay? So like right here, we're saying, let's say you were going to take some stuff and divide it amongst no one. Well, that no one gets nothing because there's no one to divide it with. You see what I'm saying? Doesn't matter how much stuff you have. If you're going to give it to no one, then they get nothing. And that's what this one is trying to say right here. Now, this one's a little different down here, okay? So this is saying how much of, let's type this out because that may clarify here the second part. It does for me, I just don't know how it does for other people. So the second part is saying how much of 0, which we'll say is nothing, is in something, question mark. Well, like let's say, again, I'm gonna use an apple. I don't know why I'm thinking of apples. But if I had 1 apple, how much of nothing is in an apple? Now, some students say there's no nothing in an apple because you have an apple. Well, actually, there's a lot of nothing in an apple or a Hot Wheel or whatever you want to compare this with. There's so much of it that mathematically we say it's undefined. And undefined just tells us that there's an infinite amount of nothing. That's my infinity symbol, by the way. I assume you could do a better one, but either way. There's an infinite amount of nothing in anything, okay? Because everything contains a lot of nothing, I guess. Well, mathematically speaking, anyways. So that's why it's undefined. That's the difference between the two. So you're going to have to be careful because they're going to give you these types of problems on the assignment. 0 divided by anything is just 0. And they may make it look like a fraction like this. 0 divided by something, I don't know, 10. Still 0. No, but anything, let's say you took any number and you divided it by 0. If 0 is still, if it's the divisor, like it's showing in the second part, then you have an undefined value. I believe on the assignment they say it's DNE, meaning it does not exist. Of course, these ones you can just type in 0. But the 0 on these ones is the dividend. That's the difference. If 0 is the dividend, you can get 0 as a quotient. If it's your divisor, then we can't define that. So DNE.